Okay, tonight we're going to talk about fractions, one of everybody's favorite things in mathematics. And we're going to do a little activity together, but before we do that activity, I want to preface it with some basic understandings of fractions, which I guarantee children even in high school and adults may not really have. So I'm going to walk you through that. There will be a folder available for you to download that'll have two folders inside of it. One are the papers that we're using tonight, and one are the papers that I'm using for this presentation before we begin. From the time that students are in kindergarten, when they do some computation in mathematics, they need to label it with a unit. 3 cats, 4 houses, 6 giraffes, 8 dinosaurs, all of that. If fractions were only started that way, it would make a lot more sense from the get-go. Here's a picture. If you have 2 crabs plus 1 crab, you have 3 crabs. If in the beginning, students had to label their fractions with words so they could connect it to what they know with whole numbers, it would be easier. You can see a picture of 2/4 plus 1/4 equals 3/4. And you can see the 3/4. This is before you get into any figures. In subtracting, you have 3 soccer balls minus 2 soccer balls equals 1 soccer ball. And so down below, we have 3/4 minus 2/4 equals 1/4. That, if we could start fractions off like that, I think there would be many fewer problems with our fractions. Then you have this paper tonight. I'm going to fold it in half because basically this is what fractions mean. The numerator down below tells you how many equal sets or pieces something's been broken into. Equal is the important part there. And the top part tells you how many of those 4 pieces you're talking about right now. I often take the fraction bar and open it up, put the word out of, because right now we're talking of about 1 out of 4 equal sets or equal pieces. That's the out of. And here is the break and take part. You start down here, whatever you have, you're going to break it into 5 equal sets or pieces. And once you have broken it into 5 equal sets of pieces, you're going to take one, and that will be 1/5 of your set or of your piece. So these 2 papers, I think it's been run for you on cardstock, is very important. Now, the next thing that's important to understand in fraction is what is the whole that we're talking about? So let's have a look at this. If this is our whole, the value of this is 1. This is 1/2 of that. This is 1/3 of that. And this is 1/6 of that. You could see that it would come right off each other. But what if this were the whole? Then this would be a half because it's a half of that. This would be a 4th because it would take 4 of those to make that. This would be a 6 because it's 3 here and 3 here. And this would be a 12th because there's 6 here and 6 here. But what if this is our whole? That's the whole we're talking about. Then this becomes 2. This value of this is 2 if this is 1 whole, and this is 1. And actually, this is 1.5 because you could get 1 blue one in here and a half of a blue one. And this would be worth 1/3 because 3 of those will fit in here. And what if this is the whole? Since it takes 6 of those to make this, this is valued at 6. It takes 3 of those to make this, and that would be valued at 3. Takes 2 of those to make this, so the value of this would be 2. And there's 1, so that's 1. But it's so important to know what the whole is. If you don't know what your whole is, you can't possibly know what a fraction of it is. So to prove that, I'm asking you, how much is this? Of course, you have no idea. You don't know if that's the whole, you don't know how big the whole is and how much is that, and how much is that, you have, oops, sorry, you have no idea. So let's take a look. If this is your whole, then you know how much that is. There's 1, 2, 3, 4, 5, 6 of them in there. So that's value is 1/6. For this, it appears 4 of them will fit in here, one right side up, one upside down in here. So the value of that is 1/4. And here, 5, 6, 7, 8, 9, 10, 11, 12. 12 of those would fit in here. So the value of that is 1/12. Here, the value of this is 1/3 because it takes 3 of those to make that. Down here, it takes 1, 2, 3, 4, 5, 6 to make the whole. So the value of that is 1/6. It's really important to know what your whole is before you can even consider what your fraction is. Now, you will hear a lot in mathematics when they're learning fractions about a unit fraction. Well, I've talked to you about units when you talk in kindergarten about they label them as cats or giraffes or dinosaurs. The unit here is elephants. We're counting how many elephants there are, and our unit is 1 elephant. If you're counting a bunch of carrots, your unit is 1 carrot. A whole lot of meters, your unit is a meter. Your unit is a gallon. Your unit is a square mile. Your unit is a pound. If this is 1/4, 1 out of 4 pieces to make the whole, and you're counting fourths, 1/4, 2/4, 3/4, 1/4 is your unit fraction. As long as the numerator is 1 and you're talking about just one of them, like here, we're talking about just one of these, 1/4 is your unit fraction. If you're talking about a bunch of fifths, 1/5 is your unit fraction. So what we're getting to tonight, the lesson that we're going to participate in tonight is about equivalent fractions, but you can't jump to equivalent fractions without the basic understanding of fractions that I have just gone through rather quickly. So equivalent means the same value, but a different name and a different picture. The value of a dime and 2 nickels is the same, but they have a different name. This is a dime, those are nickels, and there's a different picture. 1 dime, a nickel, and 5 pennies, all the same value, but different names and different pictures. 1 yard and 3 feet, same value, different pictures, different names. 1 gallon, 4 quarts, same thing, same value, different pictures, different names. 1 full day in 24 hours, same value, different name, and different pictures. Included in this set of the paper documents from my presentation are some examples of equivalent fractions. If you take 1/2 and hold this down, every place it comes evenly, it's equivalent. It's the same value, but it's a different picture and a different name. Doesn't work real well with thirds, but 1/2 is the same as 1 2/4. 2/4 and 1/2 have the same value, different name, different picture, but they're equivalent fractions. We can go down here to 3/6. 3/6 is a half. If you have 3/6, you have half of your 6/6. That's a half, really. 3/6, 1/4, 1/2 are equivalent. Same value, different name, different pictures. And we can go on to 4/8 and 5/10 and 6/12, 8/16, 9/18, 10/20, and 12/24 are all equivalent fractions because they're the same value with different names and different pictures. In all of my 50+ years of teaching, I have always talked about equivalent fractions as aliases. right up here in this top row, and these are left so you can fill in, this is 1 out of 2, this is 1 out of 3, 1 out of 4, 1 out of 5, 1 out of 6. In fact, this is a good opportunity for me to show you how, I have a plastic sleeve here. That's, as part of your packet, you have a plastic sleeve, and the beauty of plastic sleeves is you can put papers into them and use a dry erase marker to write on top and write it off if you have more than one child you want to work with on this. So this is 1/2, 1/3, 1/4, 1/5, and what is this? 1, 2, 3, 4, 5, 6, 7, 1/7. Okay, now this is the real guy. This is the FBI agent right here. And as we go down below, just by looking at the color, you can tell they're all equivalent to 1/2, or all equivalent to 1/3, or 1/4, or 1/5, or 1/7. But they have different names. There are 2 total pieces here, and one of them is colored blue. There are 4 pieces here, and 2 of them are colored blue. I'm not going to go through this whole thing, as you can tell, but there are 6 pieces here in total, and 3 of them are colored blue. You can see that when you finish, you have all equivalent fractions. They're aliases. If an FBI agent put on a mustache, changed his hair color, his hairstyle, changed his name, picked up an accent, chances are if you were his sister or his brother, you would still recognize him. But he would look different, and he would obviously go by a different name. I'm trying very hard to keep out of computation with fractions today. But I just have to tell you, when they say multiply the top and the bottom by the same number, you get an equivalent fraction. Okay, yes, you do. But when you multiply this 2 pieces by 2, you get 4 pieces. And you multiply the 1 piece you're talking about by 2, it's cut in half into 2 pieces. It's so important that students are given the understanding of what's going on behind those little rules that people make up and throw about. But again, equivalent fractions, and that's all we'll spend on that tonight. I teach a 4-day course on that for teachers at the Summer Academy, so we're not covering it all tonight. Now, fractions of a set are confusing, because in fractions of a set, the pieces can be different colors, they can be different shapes, and it's somehow not a lot of time is spent on that early, and then they're just expected to understand it from working with a fraction of a shape. But here, let's count how many are in our whole, because that's our numerator. How many do we have in all? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I think I should have put one more in there. But 19 is always our denominator. But when I say what fraction of those are green, you say 1, 2, 3, 4 over 19ths. If I say what fraction of those are, let's see, large shapes, 1, 2, 3, 4, 5, 6, 7 out of 19, 7 19ths. What are green shapes? 4 out of 19 polygons. This is not a polygon, by the way, because it needs to have straight sides that connect. Polygons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 19ths are polygons. Our squares, 1, 2, 2 19ths, and either red or yellow, you'd count all the red and the yellow. So that's a fraction of a set, which is different from a fraction of a whole space that we're talking about. When I work with children with fractions of sets, and I tell them I want a group that is 2/3, and I don't tell them the rest. When I say 2/3, they know they need 3. They know right away to pick 3 because they're talking about thirds. That group is going to be 2/3 yellow. So they flipped one and the group is now 2/3 yellow. Okay, if I say 3/4, they know they need 4. They just don't many. 3/4 red, and then they flip them. So that's how fractions of sets work. It's not one area, which is called the area model, and this is the set model. So we'll just have a look at this. I'm still trying to stay clear of computation, but it keeps me. This set, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 4 of them are yellow. This set is 4/12 yellow. This is 4 and this 12 altogether. But also I could put them in sets of 2 as long as I can put the whole thing in sets of 2. And that means, yes, I'm dividing this by 2 because I am grabbing them in sets of 2. There's a set, there's a set, there's a set, there's a set, okay? So now I have 2 out of 6, 2/6 yellow, which you see is the same amount as 4/12 yellow. It's just circled differently. What if I circle them in sets of 3? Yeah, there's 4 there, 4 there, 4 there. And 1 out of 3 sets is yellow. So this set is also 1/3 yellow. So this is just a little bit on sets, and if you want to connect it to the computation, you can. I think I gave you, this is thirds, fourths. If you want to do the activity that we're doing tonight with larger circles, and one thing that is in that that folder is how I have adapted this for second graders. So this lesson is good from second grade till forever if they don't have the basic understanding of fractions or just working with numbers with no understanding. And this is the sheet we're going to be working on tonight. So now we are going to proceed with our activity for tonight. And you will find everything you need in your packet. So the first thing I would like you to do okay. Oh, they each have one of these. That'll be good. Then I can do that. Let's take a look at your papers of thirds. And I'm going to, I think now, direct this as if you were at home doing it, because here we're all going to cut these out and exchange them. So when we're done, we have one of each of these 3 colors for thirds. But what you can do at home right now is you can cut out 1/3, one of your thirds of orange. Let's see if I can do this where you can see. Cut out one of the orange, one of the red, and one of the blue. And set the rest of it aside. And that's all you will need are these three pieces, so go ahead and cut them out. And then we'll just kind of place them in the circle to prove to ourselves that three of these thirds actually do complete the circle. Okay. Now in your packet, you also have a crayon. Oh, take your crayon and let's just look at one of these pieces. We're going to make a fraction here because we agree this is just one piece. So we're going to put a 1 here up near the vertex. And it takes 3 of these exactly like this to complete the whole. And so we're going to put a 3 there to show that this is 1/3. And we're going to do that with each of these 3 pieces because each of these 3 pieces is 1/3 of our whole. Okay, now let's take any one, take the orange one, for example, it doesn't really matter. And I want you to fold that in half. So it forms like an ice cream cone here. Fold it in half. Like that. Open it up. And on the back, where you don't have 1/3, trace with your crayon, trace that line. Now, what if we had done this to each one of these pieces, all 3 of them? How many pieces would we have then? We'd have 1, 2, 3, 4, 5, 6. So this is 1 piece out of 6 pieces it would take to complete the circle. But this one over here is also 1 out of 6. So then the value of this piece, there's a 6 here and a 6 here. 1 elephant plus 1 elephant is 2 elephants. So 1/6 plus 1/6 is 2/6. The value of this piece is 2/6. But look, on the other side, the value of this piece is also 1/3. And so we know if they have the same value, but it's a different name and a different picture, they are equivalent. So 2/6 are in fact equivalent to 1/3. So let's take another one and we will fold it in half. And then we will fold it in half again. And we will open it up. And trace the fold lines with our crayon. My hands really do look 80 years old. All right. There. Now, what if we had cut each one of these pieces into 4 pieces? There'd be 4 here and 4 here, and 4 here. And we would have 12 pieces and they would be this shape. So what we want to do here is saying this is one piece. Out of the 12 it would take to complete a circle. So each one of these is a 12th. We need to mark it. So what is the value of this piece? Well, one cat plus another cat and another cat and another cat is 4 cats. And since these are 12ths, the value of this is 4 12ths. But look, 4 12ths has the same value as 1/3. 1/3, 4 12ths, same value, different name, different pictures, equivalent fractions. But 4 12ths is also the same value as 2/6, equivalent fractions, 4 12ths, 2/6, 1/3. Okay, now this is the most difficult fold to make, I agree, but we can do it. This is actually how Native Alaskans make their fractions. They fold them. We're going to fold this piece over until the tongue that sticks out looks about the same, in fact, as close as you can get to exactly the same as the part you folded over. I'm getting close a little bit more. Fold it over till the tongue is the same as what you folded over. I think I'm pretty close. And to prove it, I'll fold the tongue back and see what I have. Pretty close. So now when you open it up, you have 3 sections here. Let's go over them with our crayon. Now, what if every one of these had been folded into 3 pieces? We'd have 3 pieces here, 3 here, 3 here. There'd be 9 pieces. So once again, each one of these is 1 piece. But it would take 9 of these to fill a circle, so each one of these is 1/9. 1/9, 3/9, 1, 2, 3, 3/9, 1/3 equivalent. 3/9, 4 12ths, 2/6 are all equivalent to 1/3. So for now, we're just going to set those there. And if your students are younger, like 3rd grade or 2nd grade, then I would just do the big picture, not the one we're doing now. I would do that big 3rd. And to do that, you would need to run this paper on 3 different colored papers so you could cut out these pieces that are going to fit in here and use this for your masterpiece. Okay, now if you have a set of 4 different colored papers that are in 4 different colors. What did I do with mine? There. And you want to cut a 4th out of each one of these. Just 1/4. We're going to move a little more quickly through this since the understanding is already there from doing this. We can put them into the circle and prove to ourselves that we do have fourths. And now if I had done this correctly, and I didn't think, I would like you to, I want orange over here to be twelfths, which means I have to redo my red and my, if you are fortunate enough to have that come out to be twelfths, then you're good. Otherwise, I would like you to recut your orange and recut your red. And I'm going to make my orange into twelfths, my red into sixths. If you use the same colors I did, then you'll be doing the same thing. I'm going to make my orange into twelfths. And you'll see why this is important shortly. Okay, on this side, it's 1/3. But on this side, I have 4/12. For those of you who are watching on this on a video, if we're moving a little quickly for you, you can always stop and catch it up. And now I need to redo my red and have it be 6. So I don't want this one. I want this one. So the red is now 2/6, the blue or whatever, as long as your orange is 4/12. Okay, so going back now to our fourths. Leave that one. Let's take the yellow one. Let's put 1/4 on all of these because we know that they're all 1/4. And let's take the orange one right away. And the orange one, we want to fold into thirds, which means you're folding it enough, remember, so that the tongue that's sticking out is the same as what you have folded over. I was trying to go right to the point. That's about it. I think. Okay. I've taken the orange one and I've broken it into 3 equal parts. And if we had taken these and broke each one into three, we'd have 3, 6, 9, 12. So it'll take 12 of them to make a whole, and that is 1, and this is 1. And this is 1. And now perhaps you can see why it was important for me to have these and these be the same, the orange, or you can see that the little sections are the same while the big one isn't. These are 12ths. These are 3/12 here, and these are 4/12 over here. Okay, let's take another one, any color, and just simply fold it in half. And lower it down. And if every one of these are broken into 2, we had to have 2, 4, 6, 8. So this is 1 out of 8. And this is 1 out of 8. And then we'll take another one. And fold it in half. And in half again. Draw our lines. Each of these is 1, but it's 4, 8, 12, 16. These are 16ths. Okay, now this one we're not going to do. I mean, we could, my crayon's too fat to label it for one thing at this point. You could fold those in half and have 24ths, but right now I think we will just leave it as 4th. So we have 4 equivalent fractions here. We have 1/3 and 3/9 and 4/12. And we have 4 equivalent fractions here. 1/4, 2/8, 3/12, and 4/16. Now, right there. I'm just looking for that paper here. Here it is. Okay, then if you do this, if you can put this inside of your sleeve and put whatever you want on it. But I'm going to just do this one, and I want them to compare 2/6, and you can write these right down on your paper, or you can put it in your sleeve and write on the outside if it's your sleeve, because you might want to change these around and ask different questions. 2/6 and 1/3. I'm going to do 2/12 and 1/6. I'm going to do 2/9 and 3/12. And let's see. Let's try 1/6 and 3/12. And without doing any math to find out which, here they're going to pick from equal, greater than, or less than. When it comes to 2/6 and 1/3, they should be able to pick this up and say, this is 2/6 and this is 1/3. So I know that they are equivalent. So let's try 2/12. In this case, they will have to fold this back and look at 2/12 and look at 1/6. And if you put 2/12 on top of 1/6, they will also see that is equivalent. If we try 2/9 and 3/12, if you hold 2/9 and 3/12, you might not be quite sure about which is larger, so you put one on top of the other, and you see that you got them folded here. That they're not quite the same. 2/9 and 3/12. Oh, they're not showing up very well. You can see that 3/12 is larger, so it gets the larger side. And 1/6 and 1/6 and 3/12. And you can definitely see that 3/12 is larger. Okay. And you can even compare between the two circles. You can ask them about, how about 1/4 and 1/3? So then they compare this fourth with any one of their thirds and see that a fourth is smaller. And the reason it is because we're talking about unit fractions here, one of these and one of these, but this circle was cut into more pieces. So its pieces are going to be smaller than those pieces. And I will leave the rest of these for you to fill in as you would like to, but I want to show you how to tape them onto your paper so that they can flip them out and see. So you're going to take a little piece of tape here, and you can put whichever side you want. Well, the fourth, obviously, we're going to do this, but do tape them from the, first of all, put a little piece of tape out here so that when you do tape this onto out here, it will easily peel off if you want to peel it off, and it will stick back on because there's a little piece of tape there. So I've taped one up here, so I can tape another fourth here. This one I didn't tape just right. That's why I have that piece of paper out there. Piece of tape out there. So we can keep it in. Where are my fourths? Whether you have students in younger grades or in high school, I would like you to just run through the same papers I ran through with you in the presentation part, just for some basic understandings that may never have been presented to them in their work with fractions. So there you have it. I will just take you off and go here. So hopefully you have learned something about the basic conceptual understanding of fractions tonight that'll help your students in their work with fractions. And remember, the folder is going to be made available for you so that you can reproduce any of this. Thanks for joining us tonight. Bye-bye.